Welcome back to our SQL learning journey. Today we're diving into one of the most powerful aspects of SQL, aggregate functions and data ordering. Think of aggregate functions as your data analysis toolkit. Just as a statistician uses formulas to find averages and totals, SQL provides us with built-in functions to perform calculations across multiple rows of data. We'll also learn how to sort and group this data to make it meaningful and actionable. Before we begin, let me show you the sample tables we'll be working with throughout our examples. We have an employees table with 6 employees across different departments, and a products table with various items in our inventory. These realistic examples will help you understand how these concepts apply in real business scenarios. Let's start with the distinct clause, a fundamental tool for data cleanup and analysis. How many times have you looked at a dataset and wondered what are all the unique values in this column? That's exactly what distinct helps us answer. The purpose of distinct is to retrieve only unique, non-duplicate values from specified columns. It's like asking SQL to show you one example of each different value, eliminating any repeats. The syntax is straightforward. Select distinct, followed by your column names, from your table name. Notice how clean and readable this is. SQL's beauty lies in its English-like syntax. Let me demonstrate with our first example. When we run select distinct department from employees, we're asking SQL, show me each different department that exists in our company, but only show each department name once. The output gives us exactly 3 departments: sales, marketing, and HR. Even though we have 6 employees total, and some departments have multiple employees, distinct shows us only the unique department names. Our second example shows unique salaries. Notice how we get 4 different salary values: 60,000, 75,000, 62,000, and 58,000. This immediately tells us the salary range in our company and how many different pay levels exist. Here's where distinct gets really powerful. You can use it with multiple columns. When we select distinct department and salary together, we're asking for unique combinations. Look at the output. We see that sales has employees earning both 60,000 and 62,000, while marketing has employees all earning 75,000. This gives us insight into departmental pay structures. Now let's explore the count function, your go-to tool for answering how many questions. Count is probably the most frequently used aggregate function in real-world applications. Count has 3 main variations, and understanding the differences is crucial. Count with a specific column name counts non-null values in that column. Count with an asterisk counts all rows, including those with null values. And count distinct counts unique values only. Let's see this in action. Our first example. Select count asterisk as total employees from employees gives us 6. This makes sense. We have exactly 6 rows in our table, so 6 employees total. Notice how I used as total employees. This creates an alias, making our output more readable. Always think about the person who will read your results later. When we count employees in the sales department specifically, we add a where clause. This combination, count with where, is extremely common in business reporting. The result shows us that 3 out of our 6 employees work in sales. Our third example demonstrates count distinct. When we count distinct departments, we get 3, confirming that our company has 3 different departments. This is different from counting all department entries, which would give us 6. The sum function does exactly what you'd expect. It adds up numeric values. But its applications in business analytics are far more sophisticated than simple addition. The syntax is elegant, sum followed by the column name in parentheses. Remember, sum only works with numeric data types. You can't sum text fields. Our first example calculates the total payroll by summing all salaries. The result, $390,000, represents the company's total salary expense. This single query could be part of a larger budget analysis or financial reporting system. The next example shows sum's real power in business calculations. We're multiplying price times stock quantity for each product, then summing those products. This gives us the total inventory value, $111,250. This type of calculation is essential for financial reporting and inventory management. Notice how we can perform calculations within the sum function. SQL's flexibility allows you to combine mathematical operations with aggregate functions seamlessly. The average function calculates arithmetic averages, giving you the mean value of numeric columns. Understanding averages is crucial for benchmarking and performance analysis. Like sum, average works only with numeric columns and automatically excludes null values from the calculation. When we calculate the average salary across all employees, we get $65,000. This tells us that despite having different individual salaries, the typical employee earns $65,000. This is valuable for HR planning and salary negotiations. The products example calculates the average price of electronics items, $387.50. This could help with pricing strategies. You know that electronic products average nearly $400, which might influence how you price new electronic items. Minimum and maximum functions find the smallest and largest values respectively. These are essential for understanding data ranges and identifying extremes in your datasets. Both functions work with numeric, date, and even text data. With text, minimum returns the value that would appear first alphabetically, while maximum returns the one that would appear last. Our minimum examples show finding the lowest salary, $58,000, cheapest product, $25, and earliest hire date, the 10th of November, 2018. Each of these answers different business questions. What's our minimum wage? What's our most affordable product? Who's been with us longest? Similarly, our maximum examples find the highest salary, $75,000, most expensive product, $1,200, and most recent hire, the 28th of February, 2022. These help answer questions about salary caps, premium products, and recent hiring activity. Notice how minimum and maximum work with dates. SQL treats dates chronologically, so minimum gives the earliest date and maximum gives the latest date. Order by is how we sort our results, making data readable and meaningful. Unsorted data is like a library with books scattered randomly, technically complete but practically useless. The syntax includes the column names you want to sort by, optionally followed by ASC for ascending or desk for descending. ASC is the default, so you can omit it for ascending sorts. Our first example sorts employees by salary in ascending order. Look at the output. We start with Alice earning $58,000 and progress upward. This immediately shows us the salary hierarchy in our company. When we add desk, the order reverses. Now we see our highest earners first, Jane and Robert both earning $75,000. This view is perfect for identifying top performers or highest paid employees. The real power of order by emerges with multiple columns. When we sort by department ASC, then by salary desk, SQL first groups all HR employees together, then all marketing employees, then all sales employees. Within each department, employees are sorted from highest to lowest salary. This multi-level sorting is incredibly useful. Imagine sorting sales data by region, then by salesperson, then by date, creating a perfectly organized report. Group by is where SQL becomes truly powerful for analysis. It allows us to partition our data into groups and perform calculations on each group separately. Think of group by as creating separate buckets for your data. All rows with the same value in the group by column go into the same bucket, then aggregate functions operate on each bucket independently. The syntax requires that every column in your select clause, except aggregate functions, must also appear in your group by clause. This is a fundamental rule that trips up many beginners. Our first example groups employees by department and counts how many are in each group. The result shows sales has 3 employees, marketing has 2, and HR has 1. This gives us an instant organizational chart summary. When we calculate average salary per department, we see interesting patterns. Marketing averages $75,000, sales averages about $60,667, and HR has $58,000. This could indicate different skill requirements or market rates for different departments. We've covered a tremendous amount of ground today. These aggregate functions and clauses form the foundation of data analysis in SQL. You now have the tools to summarize data, find patterns, compare groups, and present results in meaningful ways. And that's a wrap for this video. Thanks for watching this video, and if you watched this far, then please give it a like, share it with your friends, and do subscribe to the channel. See you in the next one. Till then, happy learning.